Hi, my name is Jonas Grunditz, and this is my presentation of homework 5 in neural network and deep learning. The cause functions and also the activation functions were based on the material that was presented in the PowerPoint, and the functions and the activation functions and the cause functions were then adopted to this Python environment and the Python code. I didn't need to do anything with the quadratic cost function class. The cross entropy class I needed to change a little bit. The log likelihood was a little bit more problematic, um, and the derivative as well. Then the activation functions, I didn't need to add anything to sigmoid class. The softmax class needed to be changed, and the tan h and the relu classes also needed to be changed. We see that in the class in network, I didn't change anything of this. This was all fine. These two functions, I didn't need to change anything. But then in the feed forward, the feed forward were only previously based on updating the activation values for the hidden layers and not the output layer. So I didn't change much in this code, except from these two parameters, but I changed so that the code was adapted to also calculate the activation function and activation values for the output layers. The biggest function, the SGD function, in that one I added the regularization parameters and the p parameter. So if we set these to none and we don't specify any values for them, they are not going to be used. And if we want to use them, we need to set a value to them. We can see down here that the regularization and the p-value is used when we are updating the mini batch. And if they are not, if we haven't set any values to these two will not, they will not be used because they're set to none. We can also see that the regularization parameter is used for the total cost, both up here and if we are having other data sets. If we scroll down and go to update mini batches, there are some changes. For an example, we have added the regularization and the p-value, and as you can see that if the regularization is set to L2, I have added the an extra error value, which you can see in this part. If the regularization is set to L1, you can see that the error value is a little bit different, but it's similar to the one above, to L2, but it's a little bit different. And if we haven't specified either L2 or L1, it's going to be set to none of those, and it's going to be just calculating with this error value. The biases is not calculated with any more error values. If you scroll down to back propagation, the p-value is specified here, and I have done a lot of changes to this code. To start with, I have introduced two new variables, the L, which is standing for what layer we are handling, and the update is standing for if we are in the first part in the update mini batch process, or if we're in the later one. And this is important because we just want the dropout arrays to be created once, and they're going to be representative and used for all of the updates of the wages in each of the batches. and therefore we need this variable. To start with, if the p-value is set to none, the first hidden layer is going to be updated, and if the L is going to be +1 down here. So if the layer is not equal to 0 anymore, then it's going to be the output layer if we have 3 layers. If it's not, if p is not, if we want to use p and the p is therefore not equal to none, we are going to update the hidden layer first. And here you can see that if we are in the first 0, if the update is equal to 0 or 1, we're going to update the dropout. We're going to create the dropout arrays, and we're going to multiply them by the hidden layer. Here you see the first hidden layer, L is equal to 0. We are updating based on the activation of the first hidden layer, and then multiplying it by the dropout array. And here's when L is equal to 1, and that is the second hidden layer. And we are using these two because the hidden layers are in different number of nodes, and we therefore have to adapt them to the activation functions and the dropout arrays. If it's neither of those, it's going to be the output layer, which is calculated here. When we have created these two based on the 2 iterations of the first mini batch, in the iteration in the mini batch, we are going to update the first layer, which is layer equal to 0, and that's going to be based on the dropout array that we created in the first place. Then when we're updating the L plus 1, the L is going to be equal to 1, and the dropout array number 2 is going to be used, that was created over here. And if it's neither of these, it's going to be the output layer. And then at the end, we're going to append the layer to the activations, which is combiner of all the layers. So when we have the p equal to none, we're going to have 3 layers in this one, and in the 2 latest problems, when we are using a dropout, we are going to have these equal to 4 layers. I haven't changed anything to these. The accuracy, I haven't changed anything. And the total cost, you can see I added the regularization. When the regularization is equal to L2, we are calculating the cost by this. When it's equal to L1, we're calculating it's equal to this. And if it's equal to none, we're going to calculate the cost as usual, which is up here. I didn't change anything to these functions. Neither of these, neither of these. As we can see that I got the same result as the professor, so I think everything should be correct. When this is the first one, when the cost is quadratic and the hidden layer and the output layer is equal to sigmoid, then we are changing the parameters for the cost and activation functions. I can give an example of this, that this works. Should be correct. Changing the activation cost functions again. Same here, changing the activation cost functions. And as I said, everything should be correct. And if we go down here, we see that we have regularization set to L2 and also a lambda to 3.0. And if we run this, it should be correct. The same with this part. And now we're using another number of layers and another number of nodes in each layer. So if you're running this and we have the p-value, the dropout value set to 0.1. we get this result, which should be correct. And when we set the p-value to 0.5, the dropout is much higher, and we get this result, and it changes depending on what because of the dropouts. And also one thing that we need to change was that we only want to be basing our dropout function based on the test, the training set, and not the test set. And this I solved this by using the dropout in the back propagation instead of the feed forward, because the back propagation is not used when calculating the test set. So that should not be a problem, and thank you very much for listening, and have a good day.